we're going to have a look at how we can use all the theory we've learned on how to solve quadratic equations to help us solve a problem. Okay, so a lot of the time in maths, the skills that we learn or the procedures that we acquire are used to solve practical problems, and I'm hoping you'll be able to see that in today's example. So we have the width of a rectangular floor, and we're being given it as x meters. The length of the floor is 3 meters longer than its width. So let's start off with a diagram, a rectangular floor, and we're being told that the width is x. So I'm just going to put that there on the diagram. The width is x. The length of the floor is 3 meters longer than its width. 3 meters longer than its width. So there's an extra 3 meters. So we need to add on 3 meters to the width. So the width was x, and we're going to add on 3. So now we have the width is x, and the length is x plus 3. And that's the answer to part A. Now, show that the area of the floor can be written in that format. So we're not going to worry about what they've written there for a minute. We're going to think back to how we get the area of a rectangle. Well, the area of a rectangle is length by width. The length here is x plus 3, and the width is x. And so we need to multiply these two. This is distribution, and you've seen this happen before. So x times x is x squared, and plus 3 times x is plus 3x. So that's the area of the floor, and if the length and width are meters, the area is meters squared. And if you have a look back, that's what they gave us in the question. Part C, write an equation in x given that the area of the floor is 54. Well, we've just calculated the area using x and x plus 3. So we know that the area works out to be x squared plus 3x. But they're telling us in the question that the answer for the area is 54. So x squared plus 3x must be equal to 54. And that's an equation, okay, because we have unknown quantities equal to something. So there's our equation. And D, hence, find the length and width of the floor. So we have an equation, and we're going to solve it. So this is a quadratic equation, and we know that it's quadratic because of the x squared. When we're solving a quadratic equation, the first step says it must be equal to 0. Now it's not equal to 0, but that's easily fixed. It's equal to 54, so to make it equal to 0, we need to subtract 54, but of course we must do that on both sides. The second step when you're solving a quadratic equation is to factorize. So this is a quadratic trinomial, and we're going to use the guide number, which is 54, to factorize. We need factors of 54 which subtract to make 3. And the factors that work are 6 and 9. So x squared stays as it is, but 3x is split into 6x and 9x, and minus 54 stays as it is. Now, what signs should 6x and 9x have if they sum together to give plus 3x? Well, it must be plus 9 minus 6. My first group has x in common. Middle sign always down. My second group has 9 in common. And then my factors are x minus 6, x plus 9. Third step is the zero product property. So either x minus 6 is equal to 0 or x plus 9 is equal to 0. So in this first equation, I need to add 6 to both sides. And in the second, I need to subtract 9 from both sides. Now, if you have a look back, x was representing the width of the floor. Could the width of a floor be less than 0? Minus 9 is less than 0. Can the width of a rectangle be less than 0? The answer is no. So this answer is invalid in the current situation, which means the width of the floor must be 6. And then we know the length is 3 meters longer than the width. So the length must be 9.